We're going to take a look at two common triangles that are used in trig. One is the 45-45-90 triangle. It's got two 45-degree angles. And the other one is the 30-60-90 triangle. It has a 30-degree angle, a 60-degree angle, in addition to that 90-degree angle. Let's go ahead and get started with the 45-45-90 triangle. This triangle, because it has two equal angles, also has two equal sides, and it's known as the isosceles right triangle. Isosceles right triangle. So if I were to draw this, it's fairly symmetric. It's actually very symmetric. So I've got my 90-degree angle here, and I'm going to go ahead and label these two angles as 45 degrees each. We can call those 45 degrees, or 45 degrees in radians would be pi-fourths. If I want to find the sine and cosine for these, the first thing that I need to do is to work with it on the unit circle to figure out what the lengths of those sides are. Remember, the sine on the unit circle is looking for the y-coordinate, and the cosine is looking for the x-coordinate. So if I go ahead and drop this onto a unit circle, it's going to be here. My radius is 1. These two sides are the same, so I can call both of those sides length A. Let me go ahead and pull this off so you can see it a little bit better. So length A, since the sides are equal, and then a radius of 1. Pythagorean Theorem tells us then that we've got a squared plus another a squared equals 1. 2a squared equals 1. Divide both sides by 2. A squared is equal to 1/2. I'll go ahead and take a square root here. I'm going to go ahead and just use the positive since I drew this guy in quadrant 1, but we can change the signs depending on where we're landing around the unit circle. So I can call this 1 over radical 2. That's one perfectly acceptable length to use. The other way is to go ahead and rationalize this guy. So I've got 1 over radical 2. I'm going to rationalize by multiplying by another radical 2 over 2. Keep it balanced. I get radical 2 over radical 4. Now I've rationalized that denominator, and I get radical 2 over 2. This is the more common one. It really doesn't matter to me, but this one is the one that's more commonly used. So as I take a look at what this means in terms of where we are on the unit circle, I have found both my x-coordinate and my y-coordinate. So if I were to travel 45 degrees, or pi-fourths, that's going to get me here. So I've traveled 45 degrees, or pi-fourths. My triangle is going to look like this, a radius of 1, and I just found the lengths of both of those sides, and they're both radical 2 over 2. So both x and y are radical 2 over 2. So when I want the sine value, it's going to be the y, the cosine value, it's going to be the x, but they are the same whether you're talking about 45 degrees or pi-fourths radians, and you're going to get radical 2 over 2. So radical 2 over 2 and radical 2 over 2. So that returns those trig ratios. Sine is the y, cosine is the x, and they are the same. Oh, and look, I've got that really nice picture there. So let me go ahead and just redraw this in here. So I've got my 45 degree, and this is going to line up with radical 2 over 2 on the x, and it's going to line up with the same radical 2 over 2 on the y. Now let's talk about reference angles. The nice thing about these triangles is I can go ahead and take this 45 degree 45 degree triangle, and I can move it around my unit circle using these reference angles. And that means I can use these same lengths no matter where I am. Let's go ahead and move to this angle, 3 pi over 4. So that means I have traveled pi-fourths 3 times. 1, 2, 3 times, and I've landed here. So I'm at this point right here. I don't have a triangle though. It doesn't make sense to have a triangle with 3 pi-fourths as an angle. So instead, I'm going to draw in the angle that lines up with the x-axis. And I'm going to draw that in as a triangle. Well, what I have left is my reference angle. My reference angle is the angle that goes from where I landed to the x-axis. And so if we're talking radians, that's going to be another pi fourths. So my reference angle here is pi fourths. Now that I've got that reference angle, I can talk about the cosine and the sine. So I know that because I've got a 45, 45, 90 triangle, I have that nice symmetry. Radical 2 over 2 is the length on both of these legs. One, of course, is the hypotenuse. But when I'm over here in quadrant 2, I know that my x's are negative and my y's are positive. So I really want this to be a negative radical 2 over 2, but I'm going to leave that as a positive radical 2 over 2. I can label this point. Let me go ahead and move it over here. I have a negative x, negative radical 2 over 2, and a positive y, radical 2 over 2, x and y. I want cosine first. This is the x. This is going to be a negative radical 2 over 2. And then the y is going to be radical 2 over 2. Next, we want to find the cosine for 225 degrees. Let me go ahead and draw this one on a new circle. I'll draw it over here. Sometimes these angles get hard to work with, so I like to go ahead and break it down in terms of either 180 or 360. So 180 gets me here. I need to travel 45 degrees more. This also helps me with the reference angle. So I need to travel 45 degrees more. So that's going to land me here on my unit circle. So I'm landing here. This gives me another reference angle of 45 degrees. I traveled in its entirety 225 degrees, but I really just want that reference angle that lines up with the x-axis. So I can use a 45, 45, 90 triangle. Okay, so there's my reference triangle or angle. I've got pi fourths right here, but we're in degrees, so I'm going to call that 45 degrees. I'm in quadrant 3. Everything's negative. So all I need to do now is to worry about my sines, because I know I've got radical 2 over 2 because of the type of triangle. Radical 2 over 2, everything's negative. So when I put this together, both my x and my y are negative. This is my x. This guy is my y. Cosine is my x, so it's going to be a negative radical 2 over 2. Sine is my y. I'm in quadrant 3, so another negative radical 2 over 2. We can label this point, and I'm going to go ahead and do this in black. We can label this point right here at 225 degrees as the point negative radical 2 over 2, comma negative radical 2 over 2. So the key is finding that reference angle that goes between the terminal point and the x-axis. Makes it really, really nice to break these guys down. Okay, now let's go ahead and take a look at the 30, 60, 90 triangle. I'm going to go ahead and trace out 60 degrees. If this is 90, I can break that up. That would be about 60, right? This right here would be 30, 60, 90. Okay, so I've got that. Let me go ahead and erase this line right here because that's not going to be helpful to us. And let me redraw in my 60-degree angle. I'm going to draw it like this. I'm in quadrant 1, just to start here. I'm going to go ahead and pull this guy off. This is 60. This is 90. I know that these two angles need to add up to 90 degrees, and that gives me the 30-degree angle. If I were to draw in the mirror image of this guy right here, this would also be 60 degrees, and this is another 30. I end up with an equilateral triangle. So we call what we are looking at half of an equilateral triangle, or the semi-equilateral triangle. That really helps in terms of getting the values that we need. So a semi-equilateral triangle. Just enough room. We want to be able to find the sine and the cosine. So as I'm looking at this point right here, I've got an x and I've got a y. So I've got x comma y, and I know that sine is going to line up with the y coordinate, and cosine is going to line up with the x coordinate. In this semi-equilateral triangle, I have got a length of, I'm going to go back to yellow here. This hypotenuse has length 1. Draw this in here. This also has length 1 because it's equilateral. And this is length 1, which tells me that this guy right here is 1/2. I just need to find the y coordinate then. So let's go ahead and use the Pythagorean Theorem to solve for this. Let me use a different color so you can see it a little bit better. Okay, so Pythagorean Theorem. 1/2 squared plus y squared is equal to 1 squared. Y squared then is 1 minus 1/4, which is 3/4. So y is plus or minus the square root of 3/4. I'm in quadrant 1, so I'm just going to choose the positive and write that as radical 3/2. So this point that we have right here has an x of 1/2 and a y of radical 3/2. Let me go ahead and draw that out just a little bit better. So an x of 1/2, the hypotenuse is of course 1, radical 3/2. The way that I remember how these are placed is that the longer side, the radical 3/2, is across from the bigger angle, 60 degrees. The smaller side, which is 1/2, is across from that 30-degree angle. Okay, so I want to find the sine and cosine for 30 degrees. So in order to develop this, I had to do everything in terms of 60 degrees to get that equilateral triangle. Let's go ahead and put, though, a 30-degree angle on our unit circle. I'm going to switch over to green. So I want my 30-degree angle. Oops, I went green. So at my 30-degree angle, so if I were to pull this off, I have 30 degrees here. I know that the side opposite the 30 is the shorter side, which is going to be 1/2. I have 60 degrees here. The side opposite the 60-degree angle is the longer side, which is radical 3/2. And then, of course, that's 1/2. So if I want to find the sine of 30 degrees, or pi/6, the sine of 30 degrees is going to be the y coordinate, which is 1/2. The cosine of 30 degrees is going to be the x coordinate, which is radical 3/2. I want to do the same thing now for 60 degrees. This is going to give us a chance to review what we had. I think I'm still in green. So 60 degrees goes here. So this is my taller looking triangle. So 60 is here. The side opposite the 60-degree angle is the longer side, radical 3/2. 30 degrees is right here. The side opposite that one is going to be the shorter side, or 1/2. So as I put this onto the unit circle, my x coordinate is 1/2. My y coordinate is radical 3/2. So 60 degrees is going to be pi thirds. Remember, pi is 180. So just a good review there. That'd be 180 divided by 3, or 60 degrees. Let's go ahead and write both of these out. We want the sine first. So the sine of 60 is going to be the y coordinate, which is radical 3/2. The cosine of 60 is the x coordinate, which is 1/2. You do need to memorize these. Both the 30, 60, 90 triangle, the values, and the 45, 45, 90 triangle. 45, 45, 90 is a little bit easier because everything's a radical 2/2. The 30, 60, 90, it's placing the 1/2 and the radical 3/2 based on where those angles are. Okay, so now we want to go ahead and find these and use reference angles if needed. You might want a piece of scratch paper if you're working along with me. I'm going to go ahead and draw each angle on the circle, and then I'll erase it so it doesn't get super messy. We want to start with 150 degrees. First, I'd like to think of everything in terms of either a half rotation or a full rotation. So at 180, I'm 30 degrees short of 180. So that's going to get me 150 degrees. So this is 150 degrees. I do need a reference angle. The reference angle is between the terminal side and the x-axis. So I'm going to use a reference angle of 30 degrees. So if I pull this off here, I've got 30 here, 60 here. Remember, the side opposite 30 is the smaller side. That's going to be 1/2. The side opposite the 60 is the longer. So that's going to be a radical 3/2. Let's check our signs. I'm in quadrant 2. I have positive y values and I have negative x values. So I want a negative on the radical 3/2. So this point right here is negative radical 3/2, comma 1/2. I want cosine, which is the x value. That's going to be my negative radical 3/2. Next, I want the sine, which is the y value, and that's going to be 1/2. Okay, so pause if you need to. I'm going to go ahead and erase this, but pause if you need to, and we'll go on to the next one. Okay, for the next one, we're in radians now. So we want to travel 2 pi thirds. 2 pi thirds. So pi thirds divides a full rotation of pi up into 3 pieces. So there's 1 pi third, there's 2 pi thirds. So I'm going to travel here. So this is 2 pi thirds. I again need a reference angle. We call 2 pi thirds and 150 obtuse because they're greater than 90. I'm going to say greater than pi halves because I'm in radians right now. And whenever you have an obtuse angle, you always need a reference angle. And to get that reference angle, I just need to figure out what I've got left before I get to the x-axis. That's going to be pi thirds. So I've got that. That says pi thirds. So my triangle looks like this. I've got pi thirds here. Pi thirds is 60 degrees. So this is 180/3 or 60 degrees. This is my reference angle. Well, if I know that 60 degrees is here, opposite 60 is my longer side of radical 3/2. Opposite the shorter side, this is going to be pi sixths, is going to be my shorter length. So 1/2. I'm in quadrant 2, so I need a negative x. So I'm going to go ahead and grab a negative x. So this point right here, let me draw it in black. I have a negative x, so it's going to be negative 1/2, comma, positive radical 3/2. The cosine is the x, so I get negative 1/2. The sine is the y, so I get radical 3/2. Okay, so again, if you need to write some things down, go ahead and pause, but I'm going to erase this and do the next one. Okay, so now the next one, I'm at 7 pi sixths. When I'm traveling in pi sixths, those are 30-degree increments. It's going to break up a rotation of pi into sixths. So I've got 1, 2, 3. What do I want? 4, 5, 6, 7. So this right here is 7 pi sixths. Let me go ahead and erase some of these other lines here that we don't need. Okay, so that's 7 pi sixths. Again, I need a reference angle, and that reference angle is going to get me back to the axis. So this is 7 pi sixths. This time, my reference angle works me backwards. My reference angle is pi sixths. If I go ahead and blow this up and make it a little bit bigger, this is pi sixths, which means that this angle here is pi thirds. And then, of course, we've got the 90-degree angle as well. Opposite pi sixths, this is the smaller angle. I'm going to have the 1/2. Opposite pi thirds, I'm going to have the radical 3/2. but I'm in quadrant 3 where all my coordinates are negative. So I need both of these to be negative. I'm going to go ahead and label that point. And as I label this point, I have an x of negative radical 3 over 2 and a y of negative 1 over 2. So my x, that's going to be my cosine, so negative radical 3 over 2. And y is going to be my sine, so that's going to be negative 1/2. Okay, so again, go ahead and pause if you need to write some of this down. I'm going to go ahead and erase and do the next one. The next one is 300 degrees. So again, I like to compare everything to either a half rotation or a full rotation. I am almost to 360. I'm just short by 60 degrees. So that gets me to, actually that looks more like 45. That gets me to about here. I do need that reference triangle, that reference angle, and that reference angle is going to go right here. So I had gone 300 degrees. The reference angle is the angle that I needed to make up to get all the way around, and that's going to be my 60-degree angle. So if I write this up here where we can see better, I've got 60 degrees here. That guy is 30 degrees. Opposite 60 is my longer side of radical 3 over 2. Opposite 30 is my shorter side, which is 1/2. I'm in quadrant 4. I have positive x's and negative y's. So when I label the point, I'm going to label my point with a positive x, 1/2, and a negative y, negative radical 3 over 2. Cosine is my x, that's going to be 1/2. Sine is my y, and that's going to be negative radical 3 over 2. Okay, so now I want to go ahead and work with these reference angles and just work through some of these trig values. The better you've got these memorized, the less painful these are going to be. And I'll show you what I'm talking about. So for this one, I've got a something fourths. So I know my answer is going to be a radical 2 over 2. I just don't know if it's positive or negative. So I just need to figure out where this lands. 7 pi fourths. Remember, I'm going to do everything in terms of a half of a rotation or a full rotation. In terms of fourths, a half is 4 pi fourths, and a full rotation is 8 pi fourths. Okay, that's super helpful because I'm going to travel 7 pi fourths. So I am just pi fourths shy. So my reference angle is pi fourths. I am in quadrant 4. I've got positive x's and negative y's. I want to find the cosine, which is x. I know already right off the bat, I knew it was a radical 2 over 2, but because I'm in quadrant 4, it's going to be a positive radical 2 over 2. Okay, next, 3 pi fourths. So I've already got this in terms of fourths. I'm just going to be I'm going to be almost all the way to 4 pi fourths. Instead, I'm traveling here. I'm just 1 pi fourths short. This is 3 pi fourths. But right off the bat, since it was something fourths, I knew it was going to be a radical 2 over 2. It's just deciding if it's positive or negative. I'm looking for the sine value. I am in quadrant 2. All of my x's are negative, but my y's are positive. Sine is the y, so I know it's going to be a positive radical 2 over 2. Okay, those are the ones with the fourths. Those should be pretty easy. You know your answers whenever you're doing cosine of anything pi fourths or sine of anything pi fourths. It's going to be a radical 2 over 2. It's just a matter of deciding which quadrant you land in, if you're going to be positive or negative. I'm going to erase what we've got on the unit circle so we can work with the other ones. So pause if you need to. Let me go ahead and just erase these. And now we're going to work with the next group, these 30, 60, 90 triangles. I know that with the 30, 60, 90 triangles, my answer is going to be either a 1/2 or a radical 3 over 2, and I don't know if it's positive or negative. I also know that when I'm constructing these, whenever I am across from a 60-degree angle, I need the bigger one. Whenever I am across from the 30-degree angle, I need the smaller of the two. 60 is pi thirds. 30 is pi sixths. Okay, so here we are at 7 pi sixths. So again, I'm going to think of everything in terms of pi and 2 pi. These are in sixths. So pi is 6 pi sixths. 2 pi is 12 pi 6. I'm traveling 7 pi sixths. So I just need to go one more beyond that. These are my little angles here. So it's going to get me to here. My reference angle then is another pi sixth. This gets me all the way around, right, to 7 pi sixths. Well, that reference angle is 30 degrees. So this tells me that the side opposite, or my y value, that's what I'm looking for, the y value is going to be my smaller side, which is my 1/2, and I'm in quadrant 3 where everything's negative. So this is going to be a negative 1/2. Okay, so the pi sixths opposite those are the smaller the smaller side, 1/2. Opposite your pi thirds or your 60 degrees is going to be your radical 3/2. Okay, let me erase this. Again, if you need to, pause or rewind and get written down what you need to write down. Okay, now negative 270 degrees. So I'm in degrees, which is great. I'm going to go negative. To go negative, I'm going to be traveling clockwise, 270. That's 90 degrees past 180. So I'm going to land here on my y-axis. This is a quadrantial angle, which is great because that means I've got just a really nice point. Let's see, my x is 0 and my y is positive 1. I'm looking for a cosine, which is my x value. So I'm going to go ahead and grab the 0. Nice and easy. Okay, next, cosine of 5 pi thirds. So again, I'm going to go ahead and draw my circle. I think in terms of pi and 2 pi. I'm in thirds, so this is going to be 3 pi thirds. This is going to be 6 pi thirds, multiplying it by 3/3. I'm just 1 pi thirds short, so I'm actually traveling here, which means that this reference angle would be that additional pi thirds. So it's going to look like this. So I've got pi thirds, which is 60 here. This guy is pi sixths. I want cosine, which is my x. X is opposite the smaller angle. So this is going to be my 1/2. I am in quadrant 4. X's are positive. I only care about the x's because I'm looking at a cosine. So I'm going to grab a positive 1/2. Okay, next, 11 pi sixths. Again, pi, 2 pi. I'm not even going to bother with pi here. 2 pi, if I multiply it by 6/6, is 12 pi sixths. So I'm just 1 pi sixths short. Pi sixth then is my reference angle. So this is going to be pi sixths. This guy is pi thirds. I'm looking for sine, which is the y value. So I need this length right here, the vertical length. Across from pi sixth, this is my smaller one, so it's going to be 1/2. But here my y's are negative, so I want negative 1/2. Okay, negative 1/2. Last but not least, 420 degrees. Remember, I'm always working in terms of pi and 2 pi, or in this case, 180 and 360. I am 60 degrees beyond that. So my reference angle then is 60. I actually traveled a full rotation to get there, but I'm going to use my reference angle of 60 degrees. I want the cosine, which is my x. So as I'm looking at this triangle here, this is going to be my 60-degree angle. Opposite my 60-degree angle is the larger side, which is radical 3/2. I'm in quadrant 1 where everybody's positive, and my answer is radical 3/2. It's really important that you memorize these. I don't necessarily want you to memorize every single answer, but know that whenever you have anything in terms of, I'll just do like cosine, any number times pi divided by 4, you know it's going to be a positive or negative radical 2/2. And this would be or sine. Any n. pi over 4. It gets a little trickier when you're dealing with a pi sixths. So whenever you're doing a pi thirds or a pi sixths, you know that you're going to get a 1/2 or a radical 3 over 2. You've got to work a little bit harder to get those. I don't think it's worth memorizing which ones turn up with sine and which ones turn up with cosine, but just remembering how they show up is important. So if you are opposite a smaller side, which is a pi sixths, or I'm sorry, a smaller angle, you have a smaller side. And if you are opposite a bigger angle, which is a pi thirds, you have a bigger side, which is going to be that radical 3 over 2. So memorize these. It's going to make your life so much easier in terms of everything that we've got to do in terms of these trig functions.